Hello, Mr. Price here, and this is your video on problem solving with ratios and everything to do with the ratio topic. Okay, you're going to see three different problems involved here of different kinds, and the idea to take away from this is not so much how to do each individual problem, but being able to sort of spot what's going on, what strategies I'm using, and then using that to apply it to other situations of varying kinds. Okay, I can't teach you, or no one can teach you, every single possible way of doing something. So what you need to be able to do is sort of see what I'm doing and then apply that to all the different kinds of situations. Okay, we're going to have a look at our first problem, which some of you might have seen in class, and it was to do with our aspect ratios with TVs. Okay. Now, some of you might remember that we had our TVs of varying different sizes, and we found out whether these were in the correct aspect ratio or not. Now, what we're particularly interested in today is the extension question here, where we wanted to make some of our own TVs which fits some certain criteria. Okay, if we look at question 2, we're being asked for the width and length of the TV screen, which stays in our aspect ratio, but the TV screen area is 3 meters squared. Now, if you want to give that a go, pause the video and see what you can come up with. But you've got two various hints here that can help you. One is going to involve algebra, and to use this, you need to make up letters for the things that you don't know yet. And you're basically just going to want to do exactly what you would do if you knew what those unknown letters were, but then just simplify with algebra where you don't. So see what you can come up with that. Pause the video and give that a go. Okay then, so let's go about working with this problem. So I'm in a bit of paper here. I'm going to have my TV screen. Okay, and my TV screen has a width and a length. Okay, and I know that the area of this needs to be 3 meters squared. Now, what I could do is I could just use my aspect ratio 4:3 and just guess various numbers, or guess various numbers that the width and length can be, and see if it works. But we want to be a little bit more mathematical than that. So, let's put some unknowns on. So, I can call the width of my rectangle A. I don't know what that is yet. I'm just going to call it A. You can call it whatever you like. I'm going to call it A. And my length I'm going to call B. Okay? I don't know what those are yet. And I know that the area of my rectangle is 3 meters squared. Okay? Area of the rectangle, 3 meters squared. Now I also know that to find an area of a rectangle, it's the same as the width multiplied by the length. So in this case, if I multiply A by B, it will also give me the area of this rectangle, which is 3 meters squared. So I can say that A multiplied by B, or AB, is 3 meters squared. Okay. Looking at my ratio, I also know that the width here will be represented by the unknown letter A, and the B will be represented under the 3 column here. And whatever values of A and B are must fit this ratio. Okay, now in this situation I might be a little bit stuck. Now with algebra, once you've gone as far as you can go, you want to try and make some kind of link between your unknowns. So in this case I have the unknowns A and B, and I want to find some kind of link between them. So I effectively only have one unknown, and the link forms that one unknown. So what I'd also want to do is, I know to make this in the same aspect ratio, I would need to multiply both sides by the same number to give us these letters. Now obviously I don't know what those are because I don't know what these letters are. So for now I'm going to multiply these by an unknown letter. Let's call that N. I'll do that to both sides. Okay. And now I can create an expression for A and B separately. So I know to get A, I start off with 4 and multiply by n. So 4 multiplied by n is 4n. And to get B, I start with 3, I multiply by n, and that gives me 3. So B equals 3n. And now I have a link between A and B. I can write it in terms of n. So now, looking back at my original equation here for the area, I've got A times B equals 3. Now I know A is 4n, and it's invisible multiplier sign there, so multiplied by B, which is 3n, and this will give me the answer 3. Okay, I can now simplify this. So 4 times n times 3 times n. I can multiply the numbers first, so 4 times 3 is 12, and n times n is n squared. So I've just tidied that up a little bit, equals 3. And now I can start to solve this. So 12n squared is 3, so I want what 1n squared is. So I'm going to divide both sides by 12. Excuse me. So n squared equals 3 divided by 12. And I've got common factors top and bottom here, so 3 over 12 is the same as 1/4. Now I don't want n squared, I would want n. So here I've divided by 12. So here, to cancel out my n squared, I'm going to square root. So n is the square root of 1/4. Now, you've got two choices here. You can either use your calculator to put the square root of 1/4 in, or the square root of 0.25. Alternatively, you know that a half times a half is 1/4. So that means the square root of 1/4 must be a half. We're not quite finished yet. We've got the value of n, but we want the length and width of our rectangle. So to get the length and width, we can go back to our original part here. So 4 multiplied by n, which is now a half, gives you a. So 4 multiplied by a half is 2. And 3 multiplied by a half is 1.5. So the TV screen, we need to have a length, a width of 2 and a length of 1.5. And you can check that is in the correct aspect ratio, and it multiplies to give 3 meters squared. As an extension, you might consider doing some unusual shapes like triangular TV screens with an area of, say, 10 meters squared, or even, if you're really daring, some trapeziums with the same aspect ratio. So length to width, length to width. Now for the trapezium, if you do want a challenge, we'll have that as an area of 10 meters squared as well. But include another aspect ratio in here. Maybe have the aspect ratio of this length to this length, C to D, must be maybe something like 3 to 5. So what will the length and width have to be if you have a trapezium where the two parallel sides are in the ratio 3 to 5? That would be quite a challenge for you, and it'd be quite enjoyable actually. Give that one a go, and if you want to check it, come and find me and I'll have a look at what you've come up with, and that'll definitely be worth some house points there. Okay, the other one I want to look at is this one, the Smarties question. So in the main part we were sharing our blue and red Smarties when we use the whole value. Okay, but I'd like to have a look at the extension question here. So we have our Smarties, and we have in the ratio 2 to 3 of blue Smarties to red Smarties. And unfortunately, Bully's going to take a third of our sweets, but then the teacher's going to replace all the sweets we lost with blue sweets, and we want the new ratio. And what is also of importance is that we're being asked to make some assumptions. So actually, there's lots of ways you could do this question, because we haven't been given really enough information to work this out. So to start to solve this, we are going to have to make some assumptions. So see and think, what am I doing? What am I assuming to do certain things? And whenever you're doing this for yourself, you should also be thinking to yourself, what assumptions are you making when doing these questions? Okay, let's give this a go. So first step, I'm going to write down my ratio. So I have 2 to 3 blue Smarties to red Smarties. Now, if I lose a third of my Smarties, then I'm going to lose a third of this and a third of this. So I'm going to have 1 and 2/3 left over. And here I'm going to have 2 and 2/3 left over. Okay, so I'm basically just doing what the question's asked me to do. Now, in total, I've lost 2/3 overall. Okay, so these 2/3 will be replaced with blue Smarties. So, I'm just going to put my 2/3 back onto here, and I will have 2 and 1/3. And then this is going to stay the same because I haven't added on any new red Smarties. So 2 and 2/3. So this isn't simplified at the moment, so I want this in its simplest form now. So let's change these into top-heavy fractions. So 2 times 3, 6 plus 1, 7/3. 2 times 3 is 6 plus 2, 8/3. And I want these to be whole numbers. So I want to cancel out this divide by 3 and divide by 3. So on both sides I'm going to multiply by 3, and I have 7 to 8. Now, if I remember, it said, what assumptions have you made for this question? So pause the video and see if you can think, what have I assumed when I've done this question? And is it a logical assumption? And we'll find that actually it's not the best assumption in the world, but it does the job. Perhaps you've done this a slightly different way with a different assumption, and you'll get a different answer to me. This is absolutely fine. As long as you can state what have you assumed when you did this question, then no one will think any less of you. So, when I did this, I've basically taken 1/3 of my blue sweets and 1/3 of my red sweets. Now what I've assumed here is that actually I'm assuming that I'm going to equally lose 1/3 of both types of sweet. But what could easily have happened is that just by chance, the bully happened to take all my red sweets, or 1/3 of just the red sweets, or 1/3 of just the blue sweets. So this isn't necessarily going to happen. Perhaps he took 1/3 of each, like I've done. So it's important that you can make assumptions from this. But well done if you came up with that. I don't immediately have any extension for that question, but possibly think up of a very similar kind of sounding one and see if you can come up with any solutions for that. Okay, we'll look at our final task now. Okay, and this is our last one I wanted to look at today. And this one isn't quite so bad, but we do have to do a bit of reading for this because it is quite wordy. Okay, the key thing to realise with these is not to panic and just do the things that you know you can do. So we have our construction team and they're making some concrete, and to make this concrete, sorry about the misspelling, they are told to use the following ingredients. Okay, so they use 500 grams of water, then 1 kilogram of pebbles and 1.75 kilograms of cement, and we want to fill this area here with the cement. Okay, and we're also told that 2 kilograms of our concrete will cover 1 meter squared of land. Okay, so we want to know how much of our ingredients do we need to make the concrete necessary to fill in this area. Okay, pause the video and give that one a try. Okay, so it's the thing to realise is that immediately we have different units here. So the first thing I'm going to do is I'm going to change all of these into the same unit, and for the sake of this I'm going to change them into slightly bigger numbers. So I'm going to have 1,000 grams of pebbles and 1,750 grams of cement. Okay, let's start to work through this problem. So, first thing I'm going to do is I'm going to write down my ratio. So I've got 500 of water to 1,000 of, was that one pebbles? I can't remember. Was it pebbles? It was pebbles. And then 1,750 excuse me, of cement. Okay, so we know that if we add up all these bits, because within this whole thing we have we're going to make cement. Okay, so if we use 500 grams of this, 1,000 grams of this, and 1,750 grams of this, we are going to make 3,250 grams of cement. Okay, and that is also 3,250 shares as well. Okay, if we ever add the ratio, that's add our parts up, that's going to be the number of shares. Okay, so now let's have a look at our area, because we need to know how much cement we need to use. So here's our shape, and it was 4 meters along the bottom and 11 meters along the top, and it had a height of 3 meters. Okay, so I know to work out the area of a trapezium. So area of a trapezium is equal to the two parallel sides added together, which is 15. You multiply by the height, and then halve your answer. A bit like how we do for a parallelogram. So work out the area of the parallelogram and then half your answer. Okay, and once you do that, either the calculator or in your heads, you'll find that's 22.5 meters squared. Okay, so now let's look at our original question again. We're told that 2 kilograms of concrete will cover 1 meter squared of land. Okay, so I can make up a ratio here, a different ratio, that says that 2 kilograms of cement will cover 1 meter squared. Okay, and we want to cover 22.5 meters squared. So we're going to put this underneath our area part of the ratio. Okay, and I want to see how much cement we need. So to go from 1 to 22.5, we've multiplied by 22.5. So I'm going to do the same to the right hand side. Okay, and then 2 times 22.5 is 45 kilograms. Okay, so this is how much cement we're going to need. So now we need to work out how much of each ingredient we need. Now we know that there were 3,250 shares in total. Okay, and we want these shares to be divided by the total amount we need, which is in this case 45 kilograms. Now this one's in grams, so we need to make sure this one's in grams as well, so that's going to be 45,000 grams. So we know that 3,250 shares equals this many grams, so we want one share by dividing by 3,250. If you do it on your calculator, we get this to be a rather long number, 13.8 84615 blah blah blah. Okay, so now we know that each one of these shares is worth 13.84615 grams. So to work out how much of each one we need, our final part is just to multiply everything by our 13.84615, etc. Okay, and if you do that, we eventually get the number 6923 grams of water, 13846 grams of pebbles, and then 24,230 grams of cement. And you could do a quick check to see if this works by adding up all the numbers, and you should find that this adds up to just shy of 45,000 grams. Okay, there's a little bit lost because of rounding errors, but that works. Okay, perhaps you'd want to consider now trying this extension question, but that's 3 different problems involving ratio. I hope that's been helpful. I recommend looking on the Moodle for further practice for you to do, but also do the extension questions I gave you in the video. Thank you very much.